Alright guys, this is the beginning of Chapter 9. In Chapter 9, we're only going to cover two sections, 9.1 and 9.2. And we're going to look at right triangles. In 9.1, we're going to cover the Pythagorean Theorem and also look at its converse. Alright, so the Pythagorean Theorem says if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So you may have remembered the Pythagorean theorem as a squared plus b squared equals c squared. A and b are the legs. They are what makes up the right angle in the right triangle. And then c is always the hypotenuse. It's the longest side opposite that right angle. You may hear sometimes people mention Pythagorean triples. A Pythagorean triple is a set of positive integers, a, b, or c, that satisfies the equation a squared plus b squared equals c squared. Basically, the two legs are whole numbers and the hypotenuse is also a whole number. So common Pythagorean triples that we'll see, but there are many out there, but like 3, 4, 5, 5, 12, 13 triangles, 8, 15, 17, and 7, 24, 25 triangles. All right, so here they want us to find the length of the hypotenuse of triangle ABC. And we want to see if it forms a Pythagorean triple. So if it comes out to all whole numbers, it will be a Pythagorean triple. We are missing the hypotenuse. So we have A and we have B. It doesn't matter what you call A, what you call B. One of the two legs is A, one is B. So to put this in our Pythagorean theorem, we're going to do 21 squared plus 20 squared is equal to c squared. So when we square 21, you end up with 441. If you square 20, you get 400. And it equals c squared. So we have 841 is equal to c squared. But we want c, we want the hypotenuse, so we're going to take the square root of both sides. So if I take the square root of 841, I end up with 29 is equal to c squared, or c, not c squared. This is a Pythagorean triple because my two sides are whole numbers, 21, 20, and then my hypotenuse is also a whole number, it's 29. So it is considered a Pythagorean triple. All right, next we are going to find x, but this time if you notice and you look at our problem, you'll see x is not the hypotenuse. It's actually one of the legs of the triangle. So we have a leg and the hypotenuse. So when I go to plug this into my Pythagorean theorem, I can do 8 squared plus x squared is equal to 20 squared. 8 squared we know is 64. 64 plus x squared is equal to 400. I will subtract 64 from both sides because I got to solve for x. So now I have x squared is equal to 336. We'll take the square root of both sides. Now I am going to check this, but I'm pretty sure it is not a perfect square. It is not. So what we need to do is we need to write it in simplest radical form. So that means we got to pull out our perfect squares. 336. Let's see. I know that 4 will go into it, but that's not the biggest. Let's try. I'm just dividing 336 by perfect squares. Okay. So I can multiply it and I can do 16, the square root of 16 times the square root of 21. The square root of 16 is 4. The square root of 21 we can't do anything with. So we have x equals 4 square root 21. All right, so here we are doing something similar to what we were doing before. We're using the Pythagorean theorem. We have a tower or an antenna here that is 75 feet tall. But, you know, you don't just leave the antennas by themselves. They do have wires supporting it. So we have a 50-foot wire that is anchored to the ground. And the wire must be anchored exactly 20 feet from the ground to the tower. So there's 20 feet here. So they want to figure out, well, how high does the wire have to go? If it's 50 feet long and it has to be 20 feet from the ground, so we got to find x. Notice we have a right triangle here. X is one of the legs. So again, we'll use our formula and solve for x. They want an exact answer and a 1 decimal place approximation. So I'm going to say we have 20 squared plus x squared is equal to 50 squared. So 400 plus x squared is equal to 2,500. And we'll subtract 400 from both sides. So I have x squared is equal to 2,100. And we'll take the square root of both sides to get x. And x as a decimal is, let's see, the square root of 2,100 is 45.8. So it would be 45.8 feet. And then an exact answer, 2,100 is nice because I know I can take 2,100 and divide it by 100. So I can break it down to the square root of 100 times the square root of 21. Square root of 100 is 10. So my answer for exact would be 10 square root 21. All right, so for the converse of the Pythagorean theorem, remember they just switch the if and the thens around. So it says if the sum of the squares of the lengths of the two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So the question they give us here is the triangle that has the side lengths of 85, 84, and 13 a right triangle? Now we can use our Pythagorean theorem to find our answer out here. You always want to look for the longest side, which is 85. So that's my hypotenuse, or my C. The two shorter sides are going to be A and B. So let's put it into our Pythagorean theorem. We want to know, does 84 squared plus 13 squared equal 85 squared? So that's really what we're trying to find out. Are the two sides equal? If I square 84, I get 7,056. If I square 13, I get 169. If I square 85, I get 7,225. So if I add 7,056 plus 169, I get 7,225, which is equal to 7,225. So it is a right triangle because the two shorter sides, the legs, when you square them and add them together, equal the third side, the hypotenuse squared. Now we can use the Pythagorean theorem or a version of it to help us look at triangles to figure out if it's an obtuse or an acute or a right triangle. If it's a right triangle, the two smaller sides squared equal the third side squared. But if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. So here, if you square your three sides and the longest side is larger than the two legs, then it is an obtuse triangle. To figure out if you have an acute triangle, you're looking at if the square of the length of the longest side of a triangle is less. So it's smaller than the sum of the squares of the two sides, then you have an acute triangle. All right, so here we're trying to figure out, do we have an acute, obtuse, or a right triangle? So again, your longest side is going to be your C. So I'm going to do 6 squared plus 11 squared is equal to 14 squared. So we get 36 plus 121 equals 196. Doesn't really equal, but we're trying to figure out what the relationship is. So maybe we'll do this. We'll make a circle here. There. So if I add 36 and 121, it is going to be 157. So 157 is less than 196. So this is my C, and my hypotenuse is greater than the two legs squared and added together. So that means that my triangle is obtuse, because the side that's the largest is C when it's squared.